Here we are now into the derivatives of the inverse trig functions. Basically, I'm going to ask you to memorize these 6 trig derivatives. However, 3 of them are very much like the first 3, so there's not really that much to memorize. Notice that the derivative of arcsine of u is u prime over the square root of 1 minus u squared. Its counterpart, cosine, its cofunction, is basically the same thing, but notice what's different, the negative. Tangent, the arctangent's derivative, u prime over 1 plus u squared. Well, arc cotangent, same but negative. Similarly, the derivative of the arcsecant of u is u prime over the absolute value of u times the square root of u squared minus 1. And arc cosecant of u is the same but negative. So all of the cos are negative. Memorize the first 3 and you'll know the second 3 because all the derivatives of the co-functions are negative. That even goes with the not inverse trig functions. Now, it's important to memorize these and know how to use them, but it might be even more useful to know how. Why are they as they are? So let's take a quick peek. There's a couple of ways to look at it. First of all, if we say, and we'll just do this for the arcsine of x, if we say that y equals the arcsine of x, remember that it's true that this is the inverse of the sine function, therefore the sine of y equals x. Remember, this is the angle, so we're saying the sine of what angle gives us x, gives us that value. So if we want the derivative, our goal here is to find dy dx, or rather prove that dy dx is what it is. We don't know the derivative of the arcsine x function without looking at that list, but we do know at this point the derivative of the sine function. So I'm going to take the derivative with respect to x implicitly, taking the derivative of both sides. The derivative of the sine of y is the cosine of y, but with respect to x, we use the chain rule, dy dx. The derivative with respect to x of x is 1. We solve for dy dx. dy dx equals 1 divided by the cosine of y. This has yet to look like what we saw on the front, so there's a couple of ways to make it look like what we saw on the other page. Let's create our reference triangle. So we started with the arcsine of x, and we said that this means, okay, so equals y, this means that the sine of what angle gives us x. Make our reference triangle. The angle is y, so put y in there. Sine is opposite over hypotenuse. So it's like x over 1, opposite over hypotenuse. Use our Pythagorean theorem, c squared equals a squared plus b squared, to find that b is the square root of 1 minus x squared. Therefore, the cosine of y, which is adjacent over hypotenuse, is the square root of 1 minus x squared. And there we have it. Plug it in here, and now we see that dy dx is 1 over the square root of 1 minus x squared. That's our derivative that we saw at the top of our notes. 1 over the square root of 1 minus x squared. This is just using the chain rule. Let's go ahead and use this derivative that we're talking about, but with the chain rule as we practice some of these problems. This is the u in question. Usually it'll be what's inside the arctrig function. So we say, first of all, our formula, u prime over the square root of 1 minus u squared. We memorize it. Well, the u is x squared, so u prime is 2x. Square root of 1 minus, u is x squared, so x squared gets squared. Yes, this is a derivative, but let's clean it up. 2x over the square root of 1 minus x to the fourth. We cannot simplify this further, so we're good. Take a look at one that was on an AP exam. The arctangent of the cosine of x, we want the derivative of that. Anything inside of our arctangent function, our arctrig function, that'll be our u. If it helps you, write down what u is and write down what u prime is, or call it du dx. If it helps you, and I recommend doing this, write down your formula for the derivative of the arctangent function. Our derivative of the arctangent function is u prime over 1 plus u squared. Now fill in with what we have. Negative sine of x is u prime, 1 plus cosine of x is the u, square it. There we go. We have it. Now you may want to write it a little bit simpler. Perhaps you say negative sine of x equals 1 plus cosine squared x. That's a little bit simpler. Sometimes you maybe even want to play around with some identities to clean it up a little bit more. That's up to you and the choices that you're given. Let's go ahead and take a look at one more of these basic ones. Inside the arcsecant, that's our u. So perhaps on the side we identify that u is this e to the 3x, u prime is 3e to the 3x. Remember, our easiest is itself times the derivative of the exponent. And then we write down our formula for the arcsecant. U prime over absolute value of u times the square root of u squared minus 1. Plug in what we have. 3e to the 3x over absolute value of e to the 3x, square root of e to the 3x is u, square it minus 1. Yes, this is a derivative, but we can clean this up, so let's do it. First of all, we know e to the 3x is an exponential function. They are always positive. So this positive function doesn't need absolute value. Therefore, we can cancel it, divide it out of the numerator as well. Another thing we can do to clean it up is e to the 3x squared is e to the 6x. So 3 over the square root of e to the 6x minus 1 is probably what you would see on a multiple choice selection. Let's go ahead and apply this. Let's take time to just do a quick review of finding the relative extrema of the function. Find any relative extrema of the function f of x equals. Now, one thing you have to really be aware of is if there are no parentheses around the x minus 2x, it's not in the arcsine function. This basically means the arcsine of x minus 2x. That's what is implied. So let's not make this more difficult than it has to be. So first, to find relative extrema, we take derivatives. So I'm going to find f prime of x. The derivative of the arcsine of x is 1 over the square root of 1 minus x squared. The derivative of 2x is 2. What do we do with our derivatives? Set them equal to 0. Solve for x. Let's watch how we do that. Add 2. Cross multiply, 1 equals 2 square root of, or perhaps, well, I won't do too many steps at once. Divide by 2 is what I was going to do at once, but that's fine. Square both sides, square it to get rid of the radical, and we have 1/4 equals 1 minus x squared. Let's see, this makes x squared equal to 1 minus 1/4 is 3/4, and therefore x equals the square root of 3 over 2. That's looking kind of nice. I recognize that from my unit circle. I think that's going to be helpful. Oops, wait a minute. Positive or negative, the square root of 3x, the square root of 3 over 2, right? X squared, so positive or negative. Okay, where do we go from here? Number line. Put our critical numbers on our number line. Negative root 3 over 2, positive root 3 over 2. Okay. Now we have to think about, we don't go past angles that are -1 and +1 when we're taking the sign. It's not in the range of angles. -1 to 1, sorry, not angles, values when we take the sign of the angles. -1 is the lowest the sine function goes, +1 is the highest the sine function goes. So as we pick our test values, just keep that in mind. Something in the middle, we'll pick that first, 0, is pretty easy to work with. plugging it into our derivative to see if it's positive or negative. That's a positive 1 minus 2. That makes a negative. Let's think about plugging in something really close to 1, like 0.9. How is this helpful? Well, here's our derivative. Plug in something really close to 1, but just smaller, and our denominator is 1 minus something close to 1. That's a really tiny value. Take the square root of it, it gets even smaller. Take 1, divide it by really, really tiny, and this whole number gets really, really big. Really big minus 2 is positive. Now the good news is picking negative 0.9 doesn't change it because we're squaring that value. If you're a little confused on that explanation, rewind, listen to it again. So what do we have? Increasing, decreasing, increasing. Relative max at the first critical value, relative min at the second critical value. We just have to plug it in and find the point. So we will say relative max is negative square root of 3 over 2. We'll find the y coordinate in a moment. Relative min, positive square root of 3 over 2. We'll find the y coordinate in a moment. Maybe I shouldn't block it off. I don't know how big that y coordinate is. Let's go to our original function and do f of negative root 3 over 2. That would be the arcsine of negative root 3 over 2 minus 2 times root 3 over 2. That'll turn into a plus because that guy's negative. Well, we know that this value occurs at negative pi over 3. Therefore, that's my value for the y coordinate, the relative max. Similarly, we can plug in radical 3 over 2, the positive version. The positive version will give us positive pi over 3. Positive here will give us minus radical 3. So pi over 3 minus radical 3. And there we have our relative max and our relative min.